guys. Boy, this snow is really a lot. I'm going to go through this lesson. I'm not sure what's going to happen on Wednesday at school, but you do need to know this. And we're still hoping for the test on Friday. Hope you're all staying warm. Hope you're all staying safe. Okay, so this is how do you tell the difference between a linear function and an exponential function? And if you're really not sure after I go through a lot of this, I would say piece of graph paper is the easiest thing to pull out. If you graph the points and you can take a ruler and make a straight line, it's linear. If you can, it's not. So, that is one of the most basic ways, but we're going to look at patterns and we're going to look at rate of change. Okay. So, table one, the first thing that I notice is that it goes up by 5, and then up by 10, and then up by 20, and then up by 40. 5, 10, 20, and 40, they're not the same number. So it's not repeatedly adding the same amount. So it's not a constant rate of change, which means that it's not linear. So basically, it's not linear. So now what makes it exponential? I want to try to find out if it's being multiplied constantly, multiplied. So I do know that 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. So it is definitely exponential. And it's because it's being multiplied by 2. Okay, so there's a pattern to the rate of change, but it's not a constant, which means it's not the same amount each time. That's what being a constant means, the same amount each time. So now if I look at this, it's going up by 3, up by 3, up by 3, up by 3, 3, 3, 3, 3, all threes. That is repeatedly adding the same amount every time, so this has to be linear. And there were notes the other day that said the difference between linear and exponential. I would look back at that, but you can also just keep this definition right there in mind. That's a great way to describe it, and it's basically vocabulary you already know. Okay, so that's linear. So now you can do regression on the calculator, and I will post a video specifically on regression. But what you want to do is you want to start at 5. And what number are you multiplying by? And then raise it to the x. Now, as long as that 5 is at 0, you don't have to do the -1 thing. So it's basically, where do I start? What am I doing? Exponent. Okay. Now for linear, I'm going to use y equals mx plus b. So I know the slope is 3 because that's the constant rate of change. And then the y-intercept is 8. Calculator. Amazing. So you type them both into y equals, and you just make sure that the equation you wrote matches the table by pressing second graph, which is table, and comparing the tables. So use your calculator. Okay, you type it into y equals. So you just type y equals, you type it in, you compare the tables. And if the table matches the equation you wrote, you know that you're right. All right? I don't know what's in my glasses, but not the point. Okay, so with linear and exponential, there are 2 points that will always determine the equation of the curve. And you can use those 2 points. Personally, for a linear, I like to have 3 because I just want to make sure. And, for exponential, honestly, I like 5, but you can do it with 2. So if I do 0, 12, I'm going to estimate it here. And then 1, 3, which I'm going to estimate here. Can I create a linear equation that passes through those? Well, yeah, I can, because I have the y-intercept. So y equals something x plus 12. So remember, 0, is always the y-intercept. And now I just need to figure out what the slope is. So it went from 12 to 3, so that's a slope of -9. And again, put it in the calculator. I can't stress this enough. Put it in the calculator. You type y equals -9x plus 12, and just make sure 0, 12 and 1, 3 are there. Okay. And then I'm going to write an exponential one. So exponential, y equals 12. What is it being multiplied by raised to the x? So what would I multiply a 12 by to get 3 as an answer? So I know that 12 divided by 4 is 3. So that's going to be 1/4. Because remember, when your brain says division, it's a reciprocal. So my brain is saying divide by 4, which is the same as multiplying by 1/4. But don't believe me. Test it on your calculator. Calculator, calculator, calculator. Okay? I can't keep saying that enough. So now they want me to go from -2 to 2 on my graphing calculator. So I'm going to type it in. And unfortunately, I don't have the graphing calculator on this computer, so I can't, but I can hold this up. But I'm going to make you another video with linear regression and exponential regression, which is super cool stuff. So y equals -9x plus 12. So you type it in. Type it in. Hopefully you can see that. You just type it in. Now, when you hit the word graph, most of us we're using this -10, +10 window, which is super cool, but they really want you to use that window. So you just hit the word window and you change the window to what they want. They want it from -2 to 2, and then they want it from -5 to 15, and then hit the word graph. So here's my line. Okay, so remember, hit the word window to change the window. Okay. All right, now I'm going to type the exponential. So y equals 12 parentheses 1/4. And you could always type 1 divided by 4. It's the same thing. Raised to the power of x. And then graph. So that's coming in red. I don't know if you can see the colors, but can you see that? Oh, yeah, that's a pretty good picture. So that's what your graph would look like. Okay. So this is a line, and I had that in blue. And then the other one that I had in red was this curve. All right, not the greatest pictures, but you get the idea. Okay, so linear, average rate of change is a constant. That means it has a slope, y equals mx plus b. Okay, so you're just looking like what's the rate of change, what's the rate of change, what's the rate of change. Okay, so now they want the rate of change from 0 to 1. From 0 to 1, it goes up by 4. 4 plus 4 is 8. From 1 to 2, it goes up by 8. 8 plus 8 is 16. From 2 to 3, it goes up by 16. This is exponential, like it shows in the equation, but you can also see 4 is not the same number as 8, is not the same number as 16. You can also notice that it's being multiplied by 2, and so is this rate of change. It's changing. So the average rate of change as x gets larger also gets larger. So the average rate of change increases. Now, that's how you know that it's definitely not a line, besides the fact that you could see the equation. All right. So the fact that the slope of an increase in exponential is always increasing is an interesting consequence, which means that, like, I've talked about this before, like if you're patient enough, exponential always wins. Because the rate of change keeps getting bigger and bigger and bigger. So like if I had a line and the original rate of change of my line is say 20, a rate of change of 4 is not a big deal. A rate of change of 8, not a big deal. 16 getting closer, but then 32, it's going to start to catch up. All right. So you just have to think about it in that way. All right. So I've got y equals 20x plus 5. So that's a y-intercept of 5. And then it's increasing by 20 each time, which is going to clearly send this off the chart, well, off the picture. So this is linear. I'm going to add the label. And now I got this one. It's starting at 5. But notice they put 150 there. Pretty smart, right? And also they're going to 6, but here they're only going to 3. Why don't I show you that on the calculator since we're like right here, and I might as well. So the first one is y equals 20x plus 5, and the window that they're using goes from x goes from 0 to 3, and y goes from 0 to 30. Okay, so that would look like that. Boop, boop, boop. Can you see it? I don't know if you can see it. I'm not really good at this. There you go. You can see it there. Okay. Now I'm going to change the window and do the exponential curve. So that's going to be 5 parentheses 2 raised to the x. And the window, the x goes from 0 to 6. And the y goes to 150. I'm going to count by tens. And it's going to look like that. So I think I go over here and you can see it better. It's going to look like that. So if I go to my table, 6 is off, but 5 is like right around here. So it's going to curve like that. It looks like that. Okay. So although the line does appear to rise more quickly, I mean, if you think about it, it's got a rate of change of 20. So at 0, we're at 5, but at 1, we're at 25, and then at 2, we're at 45. But if I look over here, at 0, I'm at 5, same point. But then at 1, I'm at 10. Yeah, the line is winning. At 2, I'm at 20. It's getting closer. At 3, I'm at 40. At 4, I'm at 80. And here at 3, I'm at 65. At 4, I'm at 85. The line is still winning, but notice what happens when I get to 5. At 5, I'm at 160. And at 5 here, I'm at 105. So, exponential winner, winner. It will always catch up because the rate of change increases. So it depends on how long you're going to wait. So if this was like one of those penny questions, if I was only going to day 4, take the line. But if I'm going to day 5, take the exponential. If the race goes on long enough, exponential will always win, always. But you got to have patience. Okay. So I'm looking at the rate of change, and the first one, it's going up by 3, up by 3, up by 3, up by 3. So this is definitely linear. So y equals 3x plus 7. Don't trust me. Trust the calculator. Well, trust me, because I wouldn't lie to you, but trust the calculator. Okay. So now the rate of change is 4, but then the rate of change is 12. 4 and 12 are not the same numbers, so this is exponential. So y equals 2, and it's being multiplied by 3. And I know that because 2 times 3 is 6, but you can always go backwards and divide. If you're not sure, do 6 divided by 2, or 18 divided by 6, or 54 divided by 18. Gonna get a 3. And then the power is x. Okay, so this is decreasing. The rate of change is 16, then it's 8, then it's 4. So this is decreasing. It's still exponential, but it's going to be decay. Got to start there. So y equals 8, and it's being divided by 2 or multiplied by a half, and then raised to the power of x. Not sure? Type it in. All you have to do is hit y equals, type it in, and just make sure that your equation creates the same table that's on the paper. Okay? All right. Now, this is going down by 16, down by 6. So this is linear. And it's going down by 16, so it makes the rate of change negative 16x. The y-intercept is 0, so you could write plus 0, but you don't really need it. Again, use the calculator. Okay, so up by 4, up by 5. Well, 4 and 5 are not the same, so it's going to be exponential. 4 is not the same as 5. Just ask my granddaughter. Oh my God, she's so excited to turn 5. All right, so I know that it's y equals 16. I know that it's increasing, but I think it's 1.25, but I'm not sure, so I'm just going to do some division. So 20 divided by 16 is 1.25. 1.25, raise to the x. And, type it in the calculator. Hit y equals, type it in, make sure that your equation produces the same table. So I would type in 16, 1.25 raised to the power of x. Second graph is table 0, 16, 120, 225. Yep, it matches. All right, this is decreasing by 20 each time, so it's linear. Y equals negative 20x, and that's the y-intercept, plus 180. That was the y-intercept there. You want to look for the y-intercept. Okay, so here it goes up by 10, then by 20, then by 40. So it is definitely not linear. So it can't be that. Oh, I wonder where the 3 went. Can't be that. So now this is where they get you. That is not the y-intercept. So it's not 2, it's 1. You can go backwards with the pattern, or you can just type in the choice and make sure that you get the same table. So use your graphing calculator. Use it, use it, use it. Okay. This thing, it's a gift. Thank you, Texas Instruments. This one was a present from Texas Instruments. Use it because you can check your work. Go with your gut, but check your work. Have a great day.